Hi everybody, and welcome to the Raspberry Pi for the older generation. Well, hi everybody and welcome back. Nice to have you back. Hope you're enjoying these videos, especially learning Python, the Python language. We use Python 3. Hopefully you can remember from an earlier video we looked at some of the Python commands. If you want to know the ins and outs of the Python commands, just do a search on Google and it will go through and explain all the commands, especially the ones we're using. Well, today we're going to be looking at ultrasonic ranging. Okay, ultrasonic ranging, and we're going to be using this. Can you see it? Yeah, the HC-SR04. HC-SR04. Now, what this does, it sends out a ping or a noise and comes back. Okay, so the transmitter is used to convert electrical signals, electrical energy, into a higher frequency. We can't hear it. It's beyond the human hearing. And it turns it into sound waves, mechanical energy. And the function sends it and receives it. Okay. We've got 4 connectors on this. 4 connectors. Hopefully you can see that. Let me just make sure you can see that. And those connectors are, the first one is a VCC, right? Then it's yeah. Then the yellow one, yellow cable, is what we call the trig. The trig, that's the one that sends out the signal. Then we got the echo, that's the one that receives it back. And then we got the VCC. This component is a 5 volts. Okay, it's 5 volts. Right, so let's hook it up. Let's hook it up to the board. So what we got? We got the red. We're going to go to this connector here. All right, it says on it ultrasonic. Hopefully you can see that. Right, so the first red one goes to the 5 volts, just like that. Then we got the, hang on, let me just make sure I got this right. Yeah, the red one. Then we got the yellow one, goes to the trig pin. Is it trig? Yep. Then the green one goes to echo. If I can just get it in. And the last one, which I've got black, goes to ground. All right. So that's it hooked up. All right, that's it hooked up. All right, I'm going to put this here, because when we do our measurements, that's going to be handy for me to put something in front of it to measure the distance. Okay, so let's go to here and let me just sort my life out. Now I don't know if you remember in the last video. Let's open our Sony. On our template, we did some changes to it because we forgot to do our save as. So what I've done, I've just quickly corrected that template. So what we do, we'll open, okay, open the template and click OK. All right, so I've quickly rearranged stuff on the template. Right. So now we will do a file save as. Right, file, so save as. I'm going to call mine Ultrasonic Ranging. Okay, Ultrasonic Ranging, right, .py for the Pi extension. There we go. Right, there is a lot of code to do in this. It's quite a big program, but it shouldn't take us too long. Right, with normal stuff, we have to import our GPIO pins as GPIO, and then we got to import time. Right, now we've got to do our attributes. So let's name our pins first. Trig pin equals 8. Now remember, sorry, I've just seen a mistake already, a typo already. Now remember, you can name your attributes whatever you want, but just remember when you're doing the follow-on code to name your attributes correctly. All right, echo pin, capital P on the pin, and that equals a pin 10. Right, so that's our 2 pins, our trig pin and our echo pin. Trig pin sends it out, echo pin receives it back. Right, then we're going to set the maximum measuring distance. So max underscore, this is all capitals, distance, right, equals 220. So that's going to give us our maximum distance of 220 centimeters. Now obviously this is not the greatest sonar in the world. You can buy better ones for the Raspberry Pi, but this is quite adequate for us to configure and look at the results. Then we need a timeout equals max MAX, yeah, underscore distance, all capitals, star 60. Calculate timeout according to the maximum measuring distance. Right, okay, so let's come down to our next one. We've got to define pulse in, PULSE, capital IN, pulse in, brackets on, pin, comma, level, comma, timeout, capital O on the timeout. Right, did I do that? No, okay, I just noticed, remember these two have to be the same. I didn't put a capital O on the timeout, so that's a capital O. So timeout, brackets off, colons, auto indent. Okay, obtain the pulse time of a pin under timeout. That's what this configuration is doing. Right, so it's T0 equals time dot time, brackets on, brackets off, enter, while, brackets on, GPIO, all capitals, dot input, brackets on, pin, brackets off, space, exclamation mark, equals, space, level, brackets off, okay, colon, enter. Okay, this gives us our auto indent. If, brackets on, time dot time, brackets on, brackets off, space, minus T0, brackets off. Yeah, got that right so far. Greater than space, time out, capital O on the out, star, 0, point, 1, 2, 3, 4, 5 zeros, 1, brackets off, colons, return, auto indent. Okay, return 0, return space 0, semicolons. Long time since we've used a semicolon in Python 3, and enter backspace. We want to be under the while, right? Pulse time equals, brackets on, time dot time, brackets on, brackets off, minus T0, brackets off, and that is 1, 1, 2, 3, 4, 5, 6 zeros. All right, enter, return, pulse time, capital T on the time. Okay, return. Just making sure everything's hunky-dory. Have I forgotten something? Let me just check. Pulse, while, if, return, time, T0, okay, if, time 0, why have I gone to, right, okay, little issue there. So we'll go back to here, enter, okay, backspace, just checking, I'm sure I typed that, no, all right, okay, T0 equals time dot time, brackets on, brackets off, and we have a second while loop. Let me just get rid of this out of the way for a minute. Time 0 equals time dot time, while, brackets on, GPIO, capitals, comma or dots, input, brackets on, pin, brackets off, space, equals, space, level, brackets off, colons, return, if, brackets on, there's 2 brackets, time dot time, brackets on, brackets off, space minus a T, a 0, brackets off, greater than hang on, let me just check this. T0 while GPIO if time.time times 0 greater than return T0 time.time brackets on, brackets off, while GPIO dot input brackets on pins bracket off equals levels brackets off colons if time.time brackets on, brackets off minus T0 brackets off greater than time, capital O for out, star, 1, 2, hang on, sorry, that's not time out. I'm jumping the gun. Okay, timeout times 0. Sorry, 0.12345 1 brackets off colons. Okay. Auto intent. Return. Brackets 0. Semicolons. Return. Okay. Then we want to come under the while loop, so it's another backspace. Pulse time, capital T on the time, equals time brackets on time.time brackets on, brackets off, space minus a T0 brackets off, star, and it's 1, 2, 3, 4, 5, 6 zeros. All right. So enter and return pulse time. Space pulse capital T time. Right. Okay, so all of that code, what that's doing for us, all of that code is colons, semicolons, colons, pulse time return. Okay. All right. Just make sure, do I need another bracket there? No, that's right. Just doesn't look right to me. Return pulse time. Right, okay. Okay, let's have a quick sip of water. Okay, so far so good. Now, we've got another define def. Let me move this out of the way. Get sonar. Capital S on the sonar. Brackets on, brackets off, colons. Return auto indent. Get the measurement results of ultrasonic module with unit centimeters. So we're going to be measuring our distance in centimeters. Okay. GPIO. A dot output. Brackets on trig pin or whatever you named it. Okay. Comma. And it's a GPIO dot high. Brackets off. Then in here, let's move this down a bit so we can all see. Then in here, we can get rid of this because I've moved it down, get rid of this. So under it's time.sleep. Time.sleep, brackets on, and it's 0, a point. 1, 2, 3, 4 zeros, 1 brackets off. All right, so that's going to sleep for 10 milliseconds. No, 10 US, whatever US is. I don't know. Anybody know? Please put it in the comments below. All right. And so time.sleep. We're now on GPIO capitals dot output, all small case, brackets on, trig pin, capital P on the pin, comma, GPIO dot low, brackets off. Make the trig pin output low level. All right, so it's not sending anything out. All right. Now we're going to do our ping times. All right. So this is to read plus time of the echo pin. All right. This next code. Ping time. Capital T on the time. Equals pulse in. Capital I on the in. Brackets. Echo pin, comma, GPIO dot high, all capitals, comma, time out, capital T on the out, sorry, capital O on the out, brackets off. Okay, read plus time of echo pin. Right, that looks all right. Pulse in, yep. Read and enter. Next, distance. Equals ping time, capital T on the time, star 340.0 space forward slash space 2.0 space forward slash space 10,000 10,000.0. Calculate distance with sound speed of 340 milliseconds. Now we know that the I know that the speed of sound is 7,067 miles per hour, or is it something like that, miles per hour? But we can't measure in miles per hour, so we're bringing it down to milliseconds. All right, we're doing it down to milliseconds. All right, so return distance, return space distance. All right, space. All right, let's come to our setup, our normal setup that we do. Let's get some of these spaces out. Okay, so first of all, GPIO.set mode, brackets on, GPIO.board, all capitals, brackets off. Then we want our GPIO.setup. pretty similar to what we've done. We've got trig pin and echo pin. So trig pin, capital P on the pin, and it's a GPIO dot out, all capitals, brackets off. Sorry, and don't forget the comma after trig pin. And then it's GPIO dot setup, brackets on, and it's echo pin, okay, comma, GPIO dot in, because remember it's receiving the signal, okay, it's receiving the signal, so we're setting it to input mode. Okay, so that's our setup, and then let's go to our loop. While true is always true, we haven't got that much more to do, guys. We haven't got that much more to do. And colons, auto indent, distance equals get sonar, capital S on the sonar, brackets on, brackets off. So that's going to get the distance. Enter. Print. Okay, so we want to print our results, don't we? We want to print what we measure, and that's going to be, you can do full quotes or half quotes. I like to do half quotes. The distance is space, colons, space, percent, point, dot, 2F, space, remember we're measuring in centimeters, and then it's quotes off, percent, yeah, why have I got 5 there? Okay, I've just seen him. Good to see it before. Good to see it before. It's percent. Okay. So we're up to 2F space CM, quotes off, percent, brackets on, distance, right, a distance, a brackets off, brackets off. Then in here we're going to put a time dot sleep, and we'll do that for 1 second. All right, and that's it, and that's the code. We got our loop. We can take this out. Let's come up, bring this up. So let's space that. All right. Just looking for typos or anything. There's a reason why that's black. Let me just check. Import time, trig pin, echo pin, distance underscore, max distance underscore equals 220, timeout equals max underscore distance star, pulse in. Pulse in. Brackets on, brackets off. Pulse level, brackets, brackets, time, brackets. Colons. Return. Why is that like that? Black. Let's save it. Right, let's save it and let's run it. Line 12. Line 12. Greater than timeout. 001. Brackets on. Brackets off. I'm missing a bracket somewhere, am I? Yeah. If. Okay, got it. I should have 2 brackets at the beginning of there. 2 brackets ons. Let's save that. Let me just clear the program and let's run it. Line 22. Line 22. GPIO. Dot. Why have I put a greater than? Dot output. Okay. Just typos really, I think. Just typos. Let's save that. And let's try again. Okay. We're running. We're running. We're running. Let's go to overhead. All right, oh, sorry, let's go back to here first of all. Let's go back to here first of all. And what I'm going to do, I'm going to put a card in front of it. Okay. Let me just stop it again. Let me just, we've got a problem, I think. Let's run it. Okay, we got an issue, we got an issue, we got an issue. Bear with me, bear with me. Control C, Control C. Let's run it again. Control C. Right. Completely stop it. Right. Start again. Control C. 47. Right, let's not worry about that. Now, I'm wondering why it's not working. It could be the circuit. Could be the circuit. I've cabled it up wrong. Let me just check. Let me just check. Okay. So, trig pin. So it should be, let me just make sure I've got this correct. Should be red, yellow, green, black. Red, yellow, green, black. What I'm going to do, I'm just going to stop the video for a minute while I check the cabling. Okay, bear with me. Sorry about this. Oh, hi guys, hi, I'm back. What it is, this unit that I was using, lucky I've got a spare. This one is kaput. It's had it. So I put a new unit on. Luckily I had a spare. I've got a couple of spares actually. I will be, when I get to 10 Patreons, I will be having a little raffle. I've got so many components and modules spare that I'll be raffling them a little package off. But that's when I get to 10 patrons. Right, enough of that. Let's start it. Okay, there we go. As you can see, oh, I'll keep getting in front of it. As you can see, there's our reading. What I'm going to do, I'm going to put this card, I'm going to put it about, I don't know, 10 centimetres, no, about there. 10 mil, yeah, that's about right. 2.4, and as I go further back, you see the distance change. I'm going back. That's as far back as I can go. So yeah, about 8 centimetres. 8 centimetres. Let me see if I can. I haven't got a tape measure. So I can't measure it. I should have got one, but yeah, that's about right. So 10, 10, 27. As I come closer, let me just, I'll go backwards and forwards overhead just to show you. So if I come to here, how far would you say that was? 3. How many centimeters would you say that was? 3 centimeters. Yeah. So if I go to there, yeah, about 3 centimeters. All right. No, it's not. Tell me why. Tell me why. Because we have to halve the distance. We have to halve the distance because we got the pin going out. That's the distance, but it's then coming back. So really, if I put that there and it's showing 2.71, it's 1.71. 1.71. Let me just show you that again. No way is that over, you know, where I am to over 2 centimeters. All right. So we have to halve the distance. All right. That's about 1 centimeter. But it will show around 2. Oh, no, don't show. Yeah. All right. So remember to halve the distance. Right. Okay. Sorry about that. My component being kaput. That will go in the bin. I'll throw it in the bin now while you're here. Okay. Glad you enjoyed. Sorry. Hope you enjoyed the video. I enjoyed making it. Learned a lot there. I know it was a bit longish. But please don't copy and paste. If you go to the Patreon, I've got all of the configurations on the Patreon page. But don't copy and paste. Try and write out and understand what code you're putting in. That's what I tried to do. So I could quite easily copy and paste, but I don't. But anyway, thanks again. Hope to see you next time in the next video. Until then, please give us a thumbs up, comment below, and subscribe. And I'll see you in the next video. Thanks a lot. Bye-bye.